So okay, now we're going to see the better solution for to find the missing numbers, right? Let's try to see the better solution for this. So I say I'll give an array here is that is 1 2 4 5. So n is equals to 5, right? The size of the array will be, what is the size of the array? The size of the array will be n minus 1, right? Size of the array will be n minus 1. Yes, right. Okay, let's try to do this. Then how can we do this using a better solution? What kind of what I'll use? What I say is I use hash. We can achieve this using hashing, right? Hash. What I say is I'll initialize a hash array. What I do here is I'll take a hash. I'll take a hash array of size of 6. Hash as size of 6. Okay. Yeah, I'll say 0 1 2 3 4 5. This is a hash array and of 6 size, right? So then I say, and I'll start iterating the array. I say 1, and the hash array will be initialized with all zeros. Hash array will be initialized with all zeros, right? Okay. Then I go to the array and I have 1 here, right? I have 1 here. Then I take this one. Then I mark 1 here in the first index of the hash array, right? Okay, I'll go to 2 and I mark it as 1 in the hash array. Then I go to 4 and I mark it as 1 here at the fourth position, at the fourth index. Okay. Then I go to 5. I'll mark it as 1, right? I'll mark it as 1. Okay. When I mark all of these elements, and I didn't mark this, right? I didn't mark this. So this is my missing number. So this is my missing number. So this is my missing number. So let's try to quickly code this thing. Let's try to understand how it's going to be done. Then I say I'll take a loop for I equals 0. First I say hash of n plus 1 of size 0. Hash of n plus 1 size, because I'll increase plus 1. Why say n plus 1? N is 5 and plus 1. Then it will be the size will be 6 for the hash array, right? Okay. I equals 0. Then I say I is less than n minus 1. N minus 1. What is n minus 1? Is the size of the array. Yes, size of the array was n minus 1. Okay. Then I will increment. Then I say this is the step 1. What I'm going to do in the step 1 is I'll mark everything in the hash array. I'll mark the hash array. Okay. Okay. So what I can do here is, so what I'll say here is, so if there is an element in the array, and if there is 1 in the array, then mark it as 1 in the hash array. I say hash array of I is equal to 1. If you find 1 in the hash, if there is 1 in the array, then mark it as 1 in the hash array. Then mark it as 1 in the hash array. Okay. This step 1 is used for marking if there are the elements in the array, right? Okay. So what I do in the step 2? Step 2. So what I'm going to do in the step 2? In step 2, I'm going to return this I. So I'm going to return the element that is not marked. So that will be that is going to be my answer, right? Okay. I'll write a loop for j equals 1, j is less than n, and j will increment. Okay. Okay, sorry, we're not using any another array, right? We're not using any other array. So let me quickly erase this thing. So I say I equals 0 and I less than n and I'll increment. Then I say if array of I is equals to 0, then return I value. If when I will become 0, if there is a 0 in the hash array, so that is going to be my answer, right? Then I say return I, return my answer. So this is for the better solution. Let's try to analyze the time complexity for this. I say here we are running two loops. This is the first loop and this is the second loop, right? So then the time complexity will be big O of n plus n, right? Then the time complexity is big O of 2n. Time complexity will be big O of 2n. And the space complexity will be big O of n. Why big O of n space complexity will be? Because we are using hash set to hash the elements, okay. So this is the better solution to find out the missing numbers in an array. So now we're going to find the optimal solution for missing. So now we're going to find the optimal solution for the missing number in an array, So the array will be, so I'll say array is 1, 2, 4, 5, and the size will be n equals to 5, right? Here the size of the array is n minus 1. So how there are two approaches, there are two optimal solutions for to find the missing number, right? One is sum of n natural numbers, and second one is XOR. Using XOR we'll find missing number, and using sum. So let's try to look for the sum first. Let's try to look for the sum. How we can do this? So as a sum of n natural numbers, what is sum of n natural numbers? What is the formula? There is a formula. We know that sum of n natural numbers is equals to n into n plus 1 divided by 2, right? This is the formula for n of sum of n natural numbers. So let's try to do this. We have got this n equals to 5, right? I say 5 into 5 plus 1 divided by 2, right? Then what will it become? Then it will become like 5 into 6 divided by 2. This is 3 times. Then the sum will become 5 into 3, that is 15. The sum here is 15, right? Sum here is 15. So let's try to find sum S2. S2 sum 2. What is sum 2? So in sum 2, we are going to add all of the elements in the array. So we're going to add these all elements in the array. So let's try to see. I'm going to add this 1 plus 2 plus 4 plus 5. Then it is 12, right? The sum 2 is 12 now. The sum 2 is 12. So I need a missing number. What do I need? I need a missing number. Then what I'm going to do is missing number is equals to S. I say sum minus S2. Sum minus S2. If I do this, 15 minus 12, then the answer will be 3. The missing number here is 3. Yes, this is how we get sum, right? This is how we get the sum. This is how we get the missing number using the optimal approach sum, right? Let's try to quickly code this thing. So okay, let's try to go here. Let's try to see how it's look when you do the code. Okay, I say code. So I'm going to do is firstly what I'm going to do is I'll say I say sum equals to n into n plus 1 and into n plus 1. Now the sum equals to n into n plus 1 divided by 2. Okay, divided by 2. Then I say I'm gonna write a loop. Then it will be like I equals 0. I is less than n minus 1. This is the size of the array, right? Size of the array. So this is size of the array. Then I say here S2 sum 2 is initially 0. Sum 2 is initially 0. Okay, right. Then I say then I say then I say S2 plus equals to array of I, array of I, array of I. Why? Because S2 y S2 plus equals to array of I. That means I need all of the array elements, and it should need to be added, right? And it should need to be added. Then I say simply return sum minus S2, sum minus S2, right? Then you'll get the missing number, right? Okay. Let's try to analyze the time complexity quickly. We're using only a single loop here, right? We're using a single loop. Then the time complexity will be big of n. What will be the space complexity? Space complexity will be big of 1. Absolutely big of 1, right? So this is an optimal approach for this is the optimal approach to solve the sum. This is an optimal approach using sum to solve the missing numbers, in the given array, right? Okay, let's try to quickly look to this XOR approach. Let us quickly look what is XOR solution. Let me give an example. Let's try to say if I do XOR A, then it will be 0. If I do XOR A, then what is this? This is 0. This is 0. Then I do the XOR to this. 0 XOR 0 will be also 0, right? Let's try to do these using numbers. 2 XOR 2. 2 XOR 2. Then what is this? 2 XOR 2 will be 0. 2 XOR 2 will be 0. Then 0 XOR will be 0 XOR 0 will be 0. But what if 2 XOR 2, 2 XOR 2, 2 XOR 2, XOR 2? What will become? 2 XOR 2 will become 0. 2 XOR 2 will be become 0, right? Then this what will become? XOR 0 XOR 0 will become 0, and then 2 XOR 2 XOR will become XOR 0 XOR 2 will become 2. What will happen? 0 XOR 2 will become 2. So this is XOR. So let us see how we are going to do this XOR solution. How we are going to find out the missing number using the XOR solution, right? Okay, let's try to look into that. So what I'm going to do here is, I say, if we have given an array that is 1, 2, 4, 5, the size will be 5, right? Okay, good. So what I'll do here is, I say XOR 1 will be sum of n natural numbers. I'll take XOR 1 will be sum of n natural numbers, that is XOR 1, XOR 2, XOR 3, XOR 4, XOR 5. I'll say XOR 2 will be my array, XOR 1, XOR 2, XOR 4, XOR 5, right? Okay, let's try to understand this quickly. So I have first to XOR of n natural numbers, that is XOR 1, XOR 2, XOR 3, XOR 4, XOR 5, right? Okay, I have the array here, that is XOR 1, XOR 2. I don't have XOR 3. Then I say I have XOR 4, I have XOR 5. What will become? This XOR will become 0. 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 Right? Then this 3 is my answer. This 3 is my answer. So this is how the XOR is going to work. Let's try to code this thing. Right? This is for sum of n natural numbers. Sum of n natural numbers. And this is the array. What is this? This is the array. And let's try to code this thing. Okay. So what I'm going to do here is, I say I initialize XOR 1 is equal to 0. Then I say I equal to 0. Then I say I is up to. So if you click here is I equals to 1, then I to n, and I plus plus. Then I say. So first I'm writing this loop for the sum of n natural numbers, right? So I'll say I equal to 1. I should start from 1. Then I say ZOR1 is equals to ZOR1 of ZOR I. Okay, right. Okay, this is first loop. I'll say it's okay, my bad. Okay, okay, I say ZOR2 is equals to 0. Then I'll write in this loop. That'll become I equals 0. I is less than n minus 1. N minus 1 is the sum of the array. Then I say ZOR2 is equals to ZOR2 of ZOR2 of ZOR I plus 1. Right? ZOR2 of ZOR I plus 1. And I say return ZOR1 XOR of XOR2. Then it is going to return me the answer. So let's try to understand. So let's try to understand time complexity for this. What is the time complexity for this loop? This loop will be big of n. What is the time complexity for this? Will it be big of n? So still the time complexity is big of n plus big of n equals to big of 2n. Still the time complexity is big of 2n. Right? So what I'm going to do is I'll modify the code. What I'm going to do is I'm going to do only a single iteration. For that I say ZOR1 equals 0, ZOR2 equals 0. Okay. Okay. What I'm gonna do is I'll write a loop I equals 0. Okay, sorry. This will be not I plus 1, this will be array of I. We should need to take the elements from the array and we should need to add that, right? It's okay. So let's try to start this thing. For this I say I'll be 0 and I'll be I to n minus 1 size of the array. And I will increment and I'm gonna say ZOR2 is equals to ZOR2 of array of I. Right? This is ZOR2. For ZOR1, I say ZOR1 ZOR I plus 1. Right now I plus 1. Why I plus 1? We have given an array that is, you all know that is 1, 2, 4 and 5. So this is 0, 1, 2, 3. Right? This is from 0 to 3. 0 to 3. But I'm not going to take the 0. So I don't want to take 0, right? What will happen here is the loop that is running 0 to 3 will be end absorbing 1. If I take I plus 1, will be end absorbing 1. It doesn't absorb 1, right? For that I am taking I plus 1. Then it will be like 1 to 4. Then it will be like it is going to from 1 to 4, right? Okay. Okay, for this, okay, we have done this. Then I'm going to say ZOR1 is equals to ZOR1 ZOR n. And in n ZOR1 should need to ZOR this n also. Then I'm going to return ZOR1 ZOR2. This is how I get the time complexity. I'm running a single loop, then the time complexity will be O of n, right? This is the time complexity. The time complexity will be O of n. The space complexity will be O of 1. So this is the optimal solution to find the missing number in the array. So ZOR is a better solution, better optimal solution to find the missing number. So okay, than sum of a natural number. ZOR is the better solution. Okay. So today we are going to find the missing number in the given array. Okay, we have an array here. Let's take this array that is 1, 2, 4, 5, right? So we have given an array and that would be of size, that would be 5. And here I'd say it's okay. So okay, what I'm gonna do here is now I'll say So okay, let's try to understand this, how to find this missing number. So I have 1, I have 2, I have 4, I have 5. Then what is the missing number? So what is the missing number? The missing number is 3, right? So we need to find the missing number, that is 3. So let's see how to find this. How to find this. So I say I'll go to first. Let us try to analyze the size of this array. That would be n minus 1. This would be n minus 1, right? Okay. What I'm gonna do here is I'll write a code. I'll try to code this thing. So I say for I equals to 0. No. For I equals 1. For I equals 1, I will be less than, I will be equal to less than n. So this is n, right? This is n. I'll be less than equal to n. Then I'll increment and I say another loop j equals 0. J will be less than equal to size of the array, that is n minus 1, and j should increment. And I say if, so I'm going to take a flag and I say flag is equals to 0. Initially it will be 0. And I say if array of I, if array of j is equal to I, then I say, then I say, uh, then I say flag is equals to 1 and breakout, right? Breakout. Then I say if, if flag is equal to 0, then I say return I, return the I value. So let's try to understand what is happening here. I'll say this is the first loop, this is the second loop. So what will happen here when one, so if I is 1, then I go through the array and I check if there is 1, yes, if there is 1, then I'll say breakout. Then I say breakout. If there is 1 in the array, then I'll say breakout. Then I say 2. If there is 2 in the array, then I'll break out. If there is 3, then I'll iterate the array and break out. If there is no 3, if there is no 3, then I say flag. If there is no 3, then I say flag is equal to flag will remain equal to 0, right? Then I'm going to return the value. Then I'm going to return I. Then I'm going to return I, that is 3. Then the answer will become 3, right? And the time complexity will be, we go of, the time complexity will be, we go of n into n at the worst case. This will be, for the worst case, we go of n into n. Time complexity will be go of n into n at the worst case. And the space complexity will be big of 1, right? Okay.